The top 10 technologies needed to reach Mars. Number 10. Radiation shielding. The harsh environment beyond our Earth's atmosphere exposes astronauts to high levels of radiation that can have detrimental effects on their health. That's where radiation shielding comes into play, for the individual, the spacecraft and the platform. One method used on the International Space Station is shielded modules. Some key ISS modules are reinforced with materials which scatter and absorb incoming radiation particles. Where spacecraft design is concerned, relying on more dense materials for protection is expensive and more mass requires more fuel to launch. Number 9. Navigation and guidance systems. In space, getting from point A to point B is no easy feat. These cutting-edge technologies are like the GPS of space exploration, helping astronauts safely reach the destination. Celestial navigation technology using stars, planets, and other celestial bodies as reference points for determining the spacecraft's position and orientation and location in space. Planning the trajectory to Mars will be challenging. Travel time is estimated at 6 to 9 months. Mission planners use various techniques, such as gravity assists from other planets, to optimize the trajectory and minimize fuel consumption. Number 8. Communication systems. Imagine being on Mars, millions of miles away from home, and still being able to have a reliable communication with your loved ones back on Earth. Sounds like science fiction, but thanks to advancements in communication systems, this is becoming a reality. Enter the NASA Deep Space Network, or DSN. The DSN consists of 3 deep space communications facilities placed approximately 120 degrees apart around the world. They are located at Goldstone, in California's Mojave Desert, near Madrid, Spain, and near Canberra, Australia. This strategic placement permits constant observation of spacecraft as the Earth rotates on its own axis. Fun fact: signals can take typically 4 to 24 minutes to travel one way between Earth and Mars, depending on the positions of the 2 planets in their respective orbits. Number 7. Mars surface mobility. Surveying and exploring the Martian terrain is a crucial aspect of Mars missions, and highly sophisticated rovers are providing scientists with valuable data and insights about the planet. The rovers move with wheels or tracks to navigate the terrain and the ability to climb slopes or traverse uneven surfaces. They can see with multiple cameras to provide stereoscopic vision, enabling scientists to perceive depth and navigate the Martian terrain more accurately. And they use robotic arms that can extend, manipulate, and collect samples from the Martian surface and carry scientific instruments. Finally, they are robust enough to withstand the harsh Martian environment with systems designed to endure extreme temperatures and dust storms. The rovers also have solar panels to harness energy from the sun. Number 6. In-space refueling. This technology has the potential to revolutionize space travel by reducing the amount of fuel we need to launch from Earth. Instead of carrying all the fuel needed for a mission on board, spacecraft could rendezvous with propellant depots or extract resources from celestial bodies like asteroids or moons. The militaries of a few spacefaring countries are using in-flight refueling, a process in which one aircraft transfers fuel to another aircraft during flight. These techniques will be the blueprint for orbital refueling. We're halfway there. If you enjoy our content, leave a comment on the video with any requests for future top 10 videos covering any topics in today's countdown or in general. We will respond, and don't forget to like and subscribe for even more interesting top 10 creations. Right, back to the countdown. Number 5. Advanced propulsion systems. To go faster and further, we need ion propulsion to help us on our way. NASA's Dawn spacecraft used ion propulsion to explore the asteroid Vesta and the dwarf planet Ceres. Ion thrusters, based on a NASA design, are also used to keep over 100 geosynchronous Earth orbit communication satellites in their desired locations. Number 4. Artificial gravity. Artificial gravity technologies provide a simulated gravitational environment to counteract the adverse effects of extended periods in micro or zero gravity. The most common approach is using centrifugal force, generated by rotation or spinning. Long spaceflights or time spent in orbital habitats create a variety of challenges like muscle and bone loss. And the absence of a clear up and down reference can affect astronauts' spatial orientation and coordination and psychological effects, including mood changes and altered sleep patterns. We will need to design rotating modules, manage their structural integrity and manage the potential motion sickness induced by rotation. Ensuring a comfortable living environment is a massive challenge that we need to address before a trip to the Red Planet can be achieved. Number 3. Entry, descent and landing systems. Another massive challenge is landing safely on the rugged terrain of the Red Planet. That's where entry, descent and landing or EDL systems come into play. These systems are specifically designed to navigate through the Martian atmosphere, endure intense heat during entry, and gently land spacecraft on the planet's surface. EDL systems are equipped with heat shields and parachutes that slow down the spacecraft, allowing it to gracefully descend towards the surface. Some designs use retro rockets or thrusters to provide additional braking power during descent. Once the spacecraft is close enough to the ground, it's time for touchdown. EDL systems employ various techniques such as airbags or powered descent engines to ensure a soft landing on Martian soil. It's like sticking a perfect landing in gymnastics. Number 2. Mars Ascent Vehicle. A Mars Ascent Vehicle or MAV is critical for sample return and any crewed missions. Its primary function is to safely launch any collected samples and/or astronauts from the Martian surface into orbit. There they can be retrieved by a separate spacecraft and returned to Earth for detailed analysis or debriefing. The MAV must be able to launch itself and its cargo from the surface into Mars orbit. When it reaches the desired orbit around Mars, it will need to incorporate sensors. Using star trackers and inertial measurement units, along with precise trajectory calculations, will ensure a successful ascent and orbital location. Most importantly, the entire process will need to be designed with redundancy and reliability in mind to minimize the risk of mission failure. And finally, the number 1 technology needed to reach Mars is advanced life support systems. Ensuring astronauts have everything they need to survive and thrive in space will arguably be the main effort. That's where life support systems come into play. These crucial systems provide astronauts with everything from oxygen and water to food and waste management solutions. Why is this so important, you may ask? Well, imagine being hundreds of thousands or even millions of miles away from Earth, with no chance of popping back home for a quick resupply. It becomes crucial to have self-sustaining systems that can provide all the essentials needed for survival. A working example of existing life support systems technology is on the International Space Station. Its systems provide oxygen, absorb carbon dioxide, and manage vaporous emissions from the astronauts and cosmonauts stationed there. Life support systems are designed to create a closed-loop environment, where resources are recycled and reused as much as possible. This means finding innovative ways to provide gravitational force, detect and suppress fires, and grow food and manage waste on board spacecraft or habitats. The future is bright for the race to the Red Planet. With each passing year, we see new innovations that can revolutionize our understanding of Mars. Our ability to explore and ultimately launch human and/or AI crews to its surface could become a reality sooner than we think. Thanks for watching, and don't forget to comment, like and subscribe to see more of our content.